Okay, I'm gonna go over a short, very brief presentation on graphing. You don't really have an assignment. There will be a practice assignment, very simple, very brief, just on your ability to graph correctly and make the correct association. You don't have to turn it in, and then I'll post a video on how to actually do it here after a bit. So that's kind of where I wanted to start. The reason I cover this, and I cover this in my face-to-face classes too, is some students really struggle with the concept of graphing, and I try to make it not, take a day and make it not so difficult to understand. I really don't even take a day. I take 15-20 minutes to try to describe what we're looking at. Some of you are probably very adept at reading graphs, and so this maybe isn't even necessary for you, and if you want to shut the video off right away, that's fine by me. Really what we're looking at when we look at a graph is just a two-dimensional or a 2D representation of data. Alright, it's just a way to illustrate what's going on with the data. First one we look at is a time series graph. Shows how a single variable changes over time. Actually, in my mind, what we're looking at really is two variables. The year is a variable, and the total disposable personal income in this case is also a variable. And so if you see over here, this side, that is what we call a schedule. And I talked a little bit about this in chapter 4, or we introduce it, but the schedule is where we list the data in tabular or chart form. But data listed in tabular form can be kind of difficult to decipher what's going on. And so it becomes a lot easier to illustrate what's going on with the data when we put it into a graph. So what we're basically looking at here is if I take this set of data here, the year 1975, and total disposable personal income of $1,181,400,000,000, and I graph it over here on this table, you can see the x-axis, which is down here, and then the y-axis would be up there. It's really hard to draw with my finger on the screen, but we've got disposable income graphed on the y-axis, and we've got the year graphed on the x-axis. So all we're doing is just figuring out what point on this whole graph, so in this whole area here, what point is indicative of 1975 and 1,181,000,000,000, and that would be this point right here. Okay. That illustrates that point. And then for each one of these then, data sets, so 1977, 1,436,000,000,000, that is right about there, right? And then we plot all these points and connect the dots by drawing a line, and now you can see, you make real quick inference. Once I know that we're looking at total disposable personal income over the course of time, we make a really quick inference that, hey, you know what? Total disposable personal income is going up, and it's going up fairly rapidly, all right? And so that's ultimately what we're trying to look at when we graph. It's just a way to get a real quick idea of what the data is trying to tell. You're probably familiar with the Cartesian coordinate system. The only part of that system that we really care about is quadrant 1. Right over there, right? That's the quadrant that we're focused on. So we don't care about all the... Typically what you're going to see on a graph is two different variables. So over here on the schedule, we've got consumption, expenditures, and income. Okay, right here. And we're looking at the bottom fifth, the second fifth, the third fifth, the fourth fifth, and the top fifth of wage earners. And then we're going to chart out their income compared to their consumption. Here we introduce this concept of this 45-degree line on the graph here. It looks like this. Since these axes, so the average income axis down here and the average consumption axis over here, since the units on the graph or the table or chart are the same, okay, each box represents 10,000, so 10,000, 20,000, 30,000, 40,000, and we've got the same units over here. This 45-degree line becomes important because it illustrates that anywhere where, if we end up on that 45-degree line, we're spending exactly what we earn. If we're above the 45-degree line, like right here, we're actually spending more than we earn, and when we're below the 45-degree line, we're spending less than we earn, so we're becoming savers at that point. And so then again, it's just a function of going through and say, all right, the bottom fifth, they're going to earn $9,676 before income. That's about right there, somewhere in there. I actually went a little bit high, and their average expenditures is going to be just a shade below 20,000 right there. Right, we go up the graph, we find where that point is, and it's at point A. Okay, we do the same, we find where point B is, it's right there, and then again we go and we connect all of these dots, and we've got a graph. The 45-degree line here becomes handy because I can see that any point above the 45-degree line, that is someone who is spending more than they actually earn. Anyone below the 45-degree line is saving. Again, brings up another concept in economics. I always ask students, how in the world can you spend more than you earn? They typically get it right. Loans, credit cards, payday sharks, whomever. Yeah, if you can borrow the money, that's one way. Transfer payments from the government. So subsidy payments to farmers. The SNAP program, Supplemental Nutrition and Assistance Program for food for poorer families. WIC, Women, Infant, and Children. Those would be transfer payments that we would lump in. So it is possible to earn less than you actually consume. The other method that a lot of times people forget about is you could be operating off of savings. Maybe some people are in this section up here, they lost their job. They're working part-time, they're trying to make ends meet, they've really cut back on consumption, they're not spending nearly as much as they used to, but they're withdrawing down some of their savings. Maybe they used to be right there, and now all of a sudden they're up in this level again, up here, and so they're drawing down on some of that money they've saved over time. Slope, I'll be right honest, I don't spend a lot of time calculating slope. I do find it very important to focus on this delta y and delta x. Delta, recall, is the Greek symbol, and it stands for change. Change, okay, and I'm going to write that up here. Change is really important when we're looking at graphs, okay? We're going to try to highlight what is being changed and why, all right? I'm going to get rid of some stuff here, get rid of that word there. And I'm going to actually try to get kind of fancy here, I think. Okay. The reason slope is important for us is determining whether we have positive or negative slope, all right? Positive slope simply means that when one variable increases, so does the other variable. Right? And so if you can see here, we've got point A right there, we've got point B right here. We follow the logical sequence. When you've got 2 points on a graph, A and B, it typically means we're starting at A and we're moving to B. And we want to see what happens when we're at A and we move to B. Right? So if we're at A and we move to B, we can see that Y increases and X increases as well in that situation. Right? And so that's really what we want to look at as far as slope is it a positive relationship between the two or a negative? When both are moving in a positive direction or moving in the same direction, we'd say that's positive. If we were at B, let me get rid of some of this stuff here. If I was at point B and I said go from point B to point A, right, now we're going from there to there. Now y is decreasing, x is decreasing as well. So a negative divided by a negative is a positive, and a positive divided by a positive is a positive. So when they're moving in the same directions, we're saying that it has positive slope. On the flip side over here, notice we're going from A to B. What's happening, y is going down, but x is increasing. Okay? X is going up. Right? And so that becomes important to understand that relationship between the two, what's going on. Okay. And then, like I said, I'm not all that concerned with your ability to calculate slope, but I do want you to understand the concept of change. So if I said, what's the change in y here? You would simply just come in and say, all right, take y2, subtract y1. The difference between the two is our change. Right? And calculating change does become pretty important for economics. A lot of times, the graphs we work with aren't going to be perfectly straight. We can still calculate the slope on it. So pretty much anything that starts down around the origin and moves outward is going to be positive. All right. It could be here and move this way. All right. We're starting close to the origin and moving outward. Anything that works kind of counterintuitive to the origin, so never really gets close to the origin, so over here is going to be negative. The whole increasing, decreasing goes back to the opportunity cost, and I'm not going to spend a lot of time on that here, but that's that idea that tried to make these about the same distance between each other, and notice the same amount of decrease in y here yields a pretty good increase in x, and then the same amount of decrease in y again yields a much smaller increase in x. Okay, and so the opportunity cost of increasing x is growing, whereas here we'd see it as decreasing opportunity cost. So like I said, I don't spend a lot of time on that. It is something to kind of be aware. I am going to do something really quick. I'm going to just get that out of the video here. And I'm going to draw a couple quick graphs. Let's see here. My handwriting is going to be terrible. I'm drawing this with my finger. Okay. Let's look at demand here for a second. All right. Demand curves will typically look something like this. Demand curves have negative relationship, right? And that's because if well here, you know what? Let's say demand for apples. And we've always got to give our graph a time measurement. So apples per week, okay? Basically what we're saying is if apples are priced right here at $4 per pound, all right, maybe I'll buy, let's say, 5 pounds per week. But if the price of apples drops to $2, I might actually buy 10 pounds of apples per week. Okay, and so I've got point A and I've got point B. All right. This really looks like something a kindergartner would work up, but hopefully it helps describe the point. When we're looking at this demand curve here, we're basically simply saying that at A, at my original price here, okay, of $4, I will buy 5 pounds of apples per week. When the price drops, right, I will increase, right, so I've got price dropping, going down, and I've got quantity going up. It's a negative demand, and that's what we're trying to illustrate here on a demand curve. A couple other things to note, and I probably should have started off with them. My apologies. We graphed price on the x-axis. Oop, excuse me, said that backwards. I'm pretty good at doing that. We graphed price on the y-axis. Got ahead of myself there. And we graph quantity on the x-axis. Okay, that's the standard for supply and demand curves when we start looking at them. We're going to look at a lot of them over the next few weeks. But that's kind of the standard method for calculating supply and demand, or looking at demand curves. Becomes pretty important to really grasp what we're talking about here, because we spend a lot of time looking at all of this stuff. So trying to move around here. I think that's what I'm going to end for the day and for this lesson. Like I said, it's nothing major. This is just something to kind of tag along. If you struggle with graphing, it's a good idea to look at and work on it. Otherwise, your job this week is to take the exam. There's no discussion. You get a little bit of a break this week, and then we start back up with Chapter 4 next week. Thank you.